Hi to everyone, this is Mr. M. Sundaran, Assistant Professor, Department of Agricultural Engineering, working in Cognado College of Engineering Technology. In the course of Cognado Battle Engineering, today's topic is about the artificial recharge techniques. What is maybe artificial recharge? Artificial recharge is the process by which the groundwater is augmented at the rate much higher than those natural conditions of percolation. Why is artificial recharge? In the most low rainfall areas in the country, is availability of at least the surface water is so low that the people depend largely on the groundwater for agriculture and domestic use. So, in order to improve the groundwater situation, it is necessary to artificially recharge the depleted groundwater aquifers. Identification of areas of over recharge. Where the groundwater levels are declining due to over exploitation, a substantial part of aquifer has been desaturated. Regeneration of water in the wells and hand pumps also slow after water sum has been drawn. The ability of the water from the wells and the hand pumps is indicated during the lean months. Where the groundwater quality is poor, there is no alternative source of water. What are the quality of source water? The problems which arise with the result of a recharge of the groundwaters are mainly related to the quality of the raw waters that are available for recharge. It generally requires some sort of treatment before using recharge installation. Major requirement for the water is to use recharge projects is to be slip free. Advantage of artificial recharge: to enhance the groundwater yield and depleted in the aquifer due to urbanization. Conservation of storage and excess of water for future requirements. To improve the quality of existing groundwater through dilution. Remove the bacterial and other impurities from the sewage and wastewater by natural filtration, so far the water is sustainable for reuse. Methods of artificial recharge. Artificial recharge is a process by which the groundwater is augmented at a rate of much greater than the natural condition of replenishment. Techniques can be probably two types: direct and indirect. Direct methods, surface and subsurface. For surface spreading, example flooding, basin, percolation, tank or steam augmentation, ditch and furrow method. For subsurface, recharge well, recharge pit, shack and dug well. For indirect, using induced recharge. Let's see about one by one. First one, surface spreading method. For surface spreading method, the method is suitable where the areas of large basin is available and the aquifers are unconfined without impervious layer above it. The rate of infiltration depends on the natural top of the soil. If the soil is sandy, infiltration will be higher than those of slitty soils. The presence of solid suspension of water used for recharge clogs soil pores leading to the reduction in the infiltration rate. It is recharge rate. The water quality also affects the rate of infiltration. The various spreading methods are below. First one, flooding method. Flooding, the method is suitable for the related flat topography. The water is spread on a thin sheet. It requires system of distribution channel and supply of water for flooding. High rate of vertical infiltration is obtained areas with undisturbed vegetation and sandy soil covering. Next one, basin and percolation tanks. The most common method of water recharge. In this method, the water is imported in a series of basins or in a percolation tank. The series size of basin may depend upon the topography of the area. In a flatter area, is a large basin. The method is suitable for alluvial soil areas where the hard rock formation. This efficiency and feasibility of the method is more in hard for rock formation where the rocks are highly fractured and weathered. Next one, stream augmentation. And seepage from the natural streams or rivers in one of the most important sources of recharge of the groundwater reservoir. When the total water supply in the stream or rivers excess the rate of infiltration, excess in the runoff. Therefore, the runoff can be arrested through check bunds or widening the stream beds through large area able to spread the river water encasing the infiltration. The size required for the check dam should be consistent successive thickness of permeable bed, whether for formation to facilitate the recharge stored water within the short period of span of time. The water stored in the structures mostly confined to the stream course, likely height normally less than 2 meters. The horns of the maximum runoff series of such check dams can be constructed. Next one, ditch and furrow system. In the areas with irregular topography, ditches and furrow provide with the maximum conductive area of recharge. Technique consists of system of shallow shaft bottomed closely packed ditches, furrow ditches, which can be used to carry the water to the source of stream canals, provide move percolation opportunity. Technique is required less soil precipitation, is less sensitive to slitting. This is example for the ditch and furrow system. Next one, B, subsurface method. Surface method structure lies between the surface and recharge groundwater directly. The important thing were recharge wells, recharge shaft and duct wells. First, recharge well. The recharge wells are two types. Injection well, water is pumped for recharge. Recharge well where the water flows under gravity. There are two types. Pumped into the well and recharge flow under gravity. First one, injection well. The injection wells are similar to the tube well. Technique suitable for augmenting the groundwater storage for the deeper aquifers by pumping in treated subsurface water. These wells can be used as a pumping wells during summer. The method is suitable for recharge of single aquifer to multiple aquifer. The recharge through this technique is comparatively costlier than the specialized technique. Next, recharge well. Recharge well means the recharge well is a shallow type of water table aquifers up to 50-meter cost effective. For effective because of the recharge can take place under the gravity flow only. Wells are two types. One is dry, another is wet. The dry wells often have bottom of the screen with the water table, such as excessive clogging. Is reported due to the release of dissolved gases or water level at the well. On the other hand, redevelopment of the method is not being for effective dry types of wells. Wet type of wells, the wells which the screen is kept lower below the water table. The wet type of wells has been found more successful. Next, pitch and shaft method. In the area where the impervious layer encountered in the shallow depth, the pits and shafts are suitable structure of artificial charge. These structures are cost effective to the recharge and acquired directly. The diameter of the shaft are only around 2 meter accommodates the water. The advantages of the shafts and pits structures does not require any large piece of land like percolation, tank and other splitting method. There is practically no loss of water in the form of soil moisture evaporation, other methods of splitting. Next, duck wells. Duck wells, the alluvial as well as hard rock as the areas where the thousands of duck wells is either gone dry or due to the considerable declining of water level. These duck wells can be used as a recharge structure. Storm water or the other surplus water from the canals can be diverted into the structures and recharged directly to the aquifer. The water from recharge should be guided through the pipe and the bottom of the well. Avoid the entrapment of bubbles within the aquifer. Next, induced recharge. In the direct method, artificial recharge involving the pumping from aquifer hydraulically connected to the surface such as perennial streams or unlined canal or lakes. The heavy pumping lowers the groundwater level. Cone of the depression is created. Lowering the water level induces the surface water replenish the groundwater. The method is effective but the steam bed is connected with the aquifer by sandy formation. This conclusion. Therefore, this is can calculate the artificial charge gives the reduction of the runoff, increase the availability of groundwater, especially in summer month, increase in the irrigation level, revival of springs, and the improvement of groundwater quality. Yet, even the full development of artificial charge and groundwater availability would remain limited. Through the groundwater recharge scheme, either naturally or artificially may not may final answer, but they could call the community effort to create the cooperation may subsequently manage the substitute of groundwater and community resources. Thank you.